Hello, everyone. Welcome to Unit 3, which is our logic section for MGF1106. And we are going to be looking at our logic, our quantified statements, how to be able to even tell what a statement is. So the first thing we need to do is just to be able to identify what a statement looks like in your homework and on your test. That's going to be your first part, being able to tell what a statement looks like. So we're going to start there, okay? So here we are. We're going to share our screen and go ahead and start looking at our information. Okay, here we are with Unit 3 cover sheet, breaking down our homework sections to us. In this section, homework 111, we're looking at statements, quantified statements, negations, and Euler circles. So in this particular video, we're going to be looking at this first part here. That's homework 11. And then we'll move into looking at our compound statements, looking at our truth tables and the different parts of that. Then converse, inverse, contrapositive, and our negations using our De Morgan's laws. And then our logical arguments, telling us something is logical or if it's valid or invalid. Right. In this particular lesson, this test, you will probably not need a calculator whatsoever on this test. This test is all going to be about rules and a lot of memorization. So your instructor will give you probably a list of things to remember and start memorizing. Some things we've already started memorizing or know from our first unit with our symbols and our vocabulary is coming back from Unit 1 into Unit 3. You may get something like this. So if you are into flashcards, this will be a good way to learn with this particular unit, using flashcards to help you with the rules and the definitions. So if you've never used flashcards before, this is a good unit to do it. So you'll have the definition of what a statement is, how to negate a quantified statement. We'll look at that today. And the rules, the wording, the symbols, how it looks. You're going to use all of this. You're going to need to know this. You will not get any help on this test. And then moving on down to our Euler circles and how that looks, what it means in words, the pictorial form. Okay. And then, of course, this is just a starter, just to get us started here with this. Of course, as you go along, you can reword these into your own words or verbiage, whatever helps you to understand. And of course, you can add more things to this sheet just to get that information or that footing that you need to get all the information studied and understood. It's very important that you get an early start with knowing this information for Unit 3. Okay. Then we're going to look at something else. When we look at our memory sheet, we're going to talk about that in just a second. Again, another form of how we're going to look at that information. Let's go ahead and start with the bottom of page 49. We're looking at being able to tell if something is a simple statement. They're giving us some examples here, and we're just simply going to write yes or no. I'm going to tell what it is or not. So it says, which of the following is a simple statement? You know, A, the dog is brown. Do we think that's a simple statement? Yes or no? The dog is brown. Yeah, it's pretty simple. The dog is brown. Okay. So yes, this is simple. Okay. Now you're going to be given some different colors too. Okay. You're going to say, hey, the sky is purple. Use some things. Now remember in the logic section, not everything is going to seem logical to you. Some of the wording or some of the things that they give us in our minds and the things that we have been taught, we know that we've never seen it before. Like the dog is yellow. Probably never seen a yellow dog before. But that doesn't mean that it's not true, that it can't happen, but it is a simple statement. All right, something that can be simply proven by just simply looking. Okay. This next one. Are we there yet? Is that a simple statement? No. Clearly, right here, we see it's not a simple statement. That's a question, right? No. No. All right, that's a question. C. Do your online homework. Right? Do your online homework. Is that a simple statement? No. Is that exclamation mark right there? It's giving us some type of like a command, isn't it? Like, eat your vegetables. Do your homework. Show up to class on time. Right? Nah, that's a command. Not a simple statement. No. Okay, it's a command. All right. Then D. Disney is the best theme park. Disney is the best theme park. Is that a simple statement? Sounds like an opinion to me. I've never been to Disney before. Have you? If you have, do you think it's the best theme park? I don't know. I kind of think that maybe Splash Waterfalls. I don't know. No, I might have a different opinion. So you see, that's an opinion, not a simple statement. Do you see that? Because your thoughts on Disney is different from my thoughts, might be different on the other person's thought. So that is an opinion and not a simple statement. So no. Do you see? So this no, no, and no, but here it's the only one so far. Is everybody okay? Yeah. So reading it, being able to tell if it's just a simple statement. All right, number 2, simple statement. They're giving us a simple statement, then they want us to negate the statement. How do we negate a simple statement? We just simply so to negate, we just add or take away. The word not in some form of the right way of speaking. So the first statement says the cat is gray. So if our initial statement is the cat is gray, then the negation of it would be, right, the cat is not gray. Right? It's the opposite, right? So negation is the opposite value of it, right? So is not, right? gray. Right? Then our second one says the pig is not pink. Okay, so if the pig is not pink here, then the negation of it would be the pig is pink. Right? The pig is pink. So negation means to change the value of the statement. So if it's saying one thing here at the beginning, you're going to change it to the opposite, the negation of it. So the cat is gray, the opposite, the cat is not gray. The pig is not pink, then the pig is pink. Okay? Let's look at negation of quantified statements. So the negation of quantified statements. A quantified statement is a statement that begins with the word all, some, or none. Okay, so all, some, or none. And we have these statements all the time. We said, look at all these people. All these people are crazy. Well, we know that's not true. Not everybody's crazy, right? Just maybe some of them, you know, right? Okay, so all, some, or none are what we call quantified statements. And see, we want to take the negation of them. So in order to do this correctly, we came up with this toggle system. And this is where these arrows come in at here, all right? So if you remember the structure, this is going to be very important. You'll see that you have all are, none are, listed here on the top. Then coming down on the bottom, you have both of your some statements. You have some are, and then some are not. When you are negating all are, you'll see that this arrow toggles down to the some are not, and then back again. So if you start off with all are and you want to negate it, it negates to some are not. If they start you with some are not, then it negates to all are. The same with none are, negates to some are, and some are negates to none are. Okay, and we're going to see how this works in real time when we look at some sentences and some statements. But this is going to be very important, being able to negate from each one of these statements and do it correctly. So when you're on the test and you have to remember, gee, oh my gosh, some are, what does that negate to? If you remember that all comes before none, then some are comes before some are not. Then you can just do your toggle, right? Your big X, I call it. Then you'll know that you're going to be able to negate properly. All right? We'll see how it works in a second. Keep this in mind now. Now these words here, all, some, none, right? We can use what we call Euler circles. Now it depends on where you're from. Euler, or if you're from the South, like I am, like Georgia, we call them, you know, Euler. Some people call them Euler. Okay, but Euler circles. So this guy, you know, he's passed on, but he did some really great research. So this guy named Euler came up with these pictorial ways of being able to show these different quantified statements using these circles. So we are going to learn how to use these circles, and they're going to become very important as we move later on down the lesson, how we can use these circles to determine the validity of our statements. Right now, we just need to be able to show them pictorially to see what's going on. So we can use all our circles to indicate our quantified statements. So when we say all are, this is what it looks like. So here we have two circles. You have circle A, the bigger circle, and circle B is all encased inside of circle A. This says all B's are A's. See that? All these B's are A's because they're encased in the A's. So all are. All right. Then you have two interlocking circles. And if you think about it, this looks like our Venn diagram, doesn't it? All right. Venn diagrams right here. But look, it says some A's are B's. So some A's are B's would be located right here. Is everybody all right with that? Because some of these A's right here are B's. Okay, some are. But in the same token, with the same diagram, some A's are not B's. So if we looked over here, aren't some of these A's right here, these A's, they're not B's. Do you see that? They don't touch the B circle at all. So some A's are not B's. So let's call this asterisk 2, like that. Okay. So you'll have this different representation that you're going to be using, but making sure that you see what's happening. So you have some are, and then some are not. Okay. And then our last depiction here, where you have two circles that don't touch. There's circle A, circle B, not touching. So that clearly shows us that no A's are B's, right? None are, or no are, depending on the statement and how it's worded. So no A's are B's, so none are. So this is how we would indicate our quantified statements using our circles. And you're going to need to know this, being able to draw your circles to represent the statements that they give you with your quantified statements, right? Again, I'm going to show you this on your memory sheet. This is referring to a memory sheet that you're going to have. Your instructor may give you this as a study guide that you need to fill in. They may also give it to you already filled in to help you study, okay? All right, let's look at some examples. Okay, now remember our toggles here now, okay? Let's do some examples. Let's negate each of the following. It says all cats are pink. So all cats are pink. So we have all are negates to what? Right? All are negates to some are not. So all are, right, negate to some are not. Okay, so our statements. Some cats are not pink. Some are not. Do you see it? So it started off with all are, and then it negates to some are not. So we simply replace all are with some are not. See what we're doing? Okay, let's roll with it then. No dogs have fleas. No dogs negates to some, right? None are, or no negates to some. Okay. So we have no dogs have fleas. Some dogs have fleas. Now remember, it's a order of the words. So as long as it's saying what you need it to say, it doesn't have to say none are all the time, right? But this says the same thing. No dogs have. Doesn't have to say none dogs have. None dogs are fleas, right? That doesn't make sense in our language. Okay, as long as it's writing the representation in our words where it makes sense. Okay, so no dogs have fleas to some dogs have fleas. All right, C. The bird can fly. Does this start with one of our quantified words? No, this is just the old simple statement, right? The bird can fly. So when we negate it, we're negating it just like by adding or removing that word not. Here we don't see it, right? It says the bird can fly, so the negation of this would be the bird cannot fly. Pay attention to if they give you a quantified statement or just a regular statement. All right, the bird cannot fly. All right, so see what we're doing now, paying attention to what they're giving us, whether it's going to be a simple statement or a quantified statement, and we're going to negate it accordingly. Go ahead and stop the video here and go ahead and finish the rest, and then we can come back and check our answers. All right, so we're ready to go ahead and continue with checking our answers with D. D, it says, some fish are not slimy. Some fish are not slimy. Have you ever met a non-slimy fish? I haven't. Okay, so here we go. Some fish are not slimy, so some are not, right? Negates to, don't look, but I'm gonna look. Okay. Some are not, negates to all are. Okay. So all fish are slimy. Okay. I know you got it on your paper. This next one, the frog has red toes. All right, does not start with one of our quantified words, just old regular statement here. So the frog has red toes. To negate it, the frog does not, that's right. The frog does not have red toes. Okay. F, some sheep are white. So some are negates to none are. So no sheep are white. Okay. I hope we're feeling it. What's going on? Using the structure that they give us at the top, all we do is using that rule. Okay, you don't have to second guess it. It may not sound logical sometimes. All you have to do is follow the rule. Okay, the bear was not green. Okay, the bear was not green. To negate it, we can say the bear was green. Okay. Then our last one, some pigs are not blue. So we have again, some are not, negates to all are. So all pigs are blue. All right, how do we feel about it? So being able to identify what a simple statement is, to negate a simple statement, to identify a quantified statement, being able to represent it using our Euler circles, and then to negate it using our toggle system. And we did some examples for both, right? So use that information, doing what we know, using that negation. That negation is really going to be pushed on the test. It's really going to be pushed on the homework, that negation of those different things. So be careful with that and get that practice in. All right. I hope this helps, and I'll see you on the next video.